Meanwhile, back at the shack. Ready for one call.
Okay, it's KBYP. Have a commenter that's left some really good questions, and they're a little bit too detailed to respond to in a typed comment, so I'm going to explain it to you. While you're listening to this, go to my video, Why Grounding Radios and Antennas is Illegal and Dangerous. By illegal, it means code violation. But go to the comments and start with a comment from the repeat troll going by this Dabo handle who's gotten caught and banned before. Not asking valid questions, but responding, retaliating, and manipulating. And I just won't put up with it. Trolls don't want to learn or know. They're trying to defend their egos and their beliefs about grounding. And everyone's got to ground everything because why? Well, somebody told me they had to. That's not right. I missed the point of this video. It's because you don't know anything. So you are saying, no, that's a deceptive game called reframing. Look that term up. Don't try to tell me what I'm saying if you don't understand it. Don't attack or try to tear me down by trying to reframe what I said away from what I said to what you think it means. This "so you are saying" meme is deliberately deceptive, and I won't play that game. Here, I'm tired of these trolls. Now it's time for me to go off on them. But along comes LiveWireGuy with some very good questions, and LiveWireGuy gets a dedicated answer because LiveWireGuy, by his questions or her questions, are demonstrating that he or she actually knows something. The problem is this stuff gets extremely complicated, and without understanding the engineering principles of electrical and electromagnetics, these questions become pretty tough. I responded about the thing with the amplifier while on the phone, which is a real pain. But, pardon the jitter. But now I'm on a computer, and I'm going to get into this in more detail. The top paragraph from LiveWireGuy is about 100 watt amp having a problem with RF, changing the bands when it keys up. So turn the amp on, key it. RF is obviously getting inside the amplifier enclosure and screwing up the control circuit so it jumps bands, which is an FCC regulation violation because suddenly it jumped bands, it's badly out of tune, it's probably generating excess harmonics, and now the signal is on another band from an amateur station, and there has not been identification given that's required by regulations. Further, this is not acceptable by simple engineering premises of the thing has to be RF hardened. And my guess is this is homebrew because FCC should have never passed something that would be this affected by RF. See, when FCC analyzes a thing, they analyze it to say, does this really work? Is it going to work correctly? What's happening with the amplifier is that there's almost guaranteed a mismatched antenna system. Instead of reflecting 5, 10, or 20 watts, it's reflecting 50, 100, or 300 watts back inside the amplifier, where the first problem is the control systems are not hardened to RF. And this is quite likely an amateur or a poor corporate hack job, because any engineer worth their salt is going to set that amplifier up without an antenna and key it down and see if it works. That's what I'm going to do. And when I see the controller freak out, I know there's a lack of RF immunity. And the response that LiveWireGuy got, try. Okay, the word try is not admissible. Try means they're guessing and don't know what the blank they're doing. Try grounding the radio and the amp. This is back to the old grounding RF away myth. This is associated with the old thing of I touched the key with the amp on and I got shocked. I got an RF burn. Well, the first or second time you get an RF burn, you'll know what it is. That is universally and always caused by a mismatched antenna system. Guaranteed. Don't believe it? Go out, disconnect the end of the transmission line, put a dummy load on the end, and you'll see the problem disappears. This is purely guessing. The manufacturer doesn't know what the blank they're doing, and they're making excuses and trying to run away from a problem that the user caused by having excessive reflective power, but that they also failed to anticipate, and they're supposed to have enough engineering talent to be able to do RF immunity, and this is an old question. There's no rocket science here. This is shielding and bypassing, and actually, you probably ought to make the control circuits external. So this doesn't happen, but we don't think. The troll guy poses a good question, though. Well, except the troll doesn't want to discuss and understand. The troll is trying to divide and disrupt. Only a fool puts his radio at the service entrance. I'm not an electrical guy, but what do you mean by that? Well, I explained that in another video. Understand when you come here and see the first video on top, that you need to go to the end, the early videos in whatever topic, and watch them all, because you can't just start at the last video I posted, because the last video is the last video, and it'll refer to and incorporate things in previous videos, and they're critical. If you'll see my video on the lightning transformer, that's why. Because if there's a big transient down the ground wire at the service entrance, or the cable TV lines or the power lines get hit, your radio is right behind the wall from that. And it's guaranteed there's going to be more noise at the service entrance. I looked at equipment on an insurance claim for a $100,000 PCI board for a computer that ran an HVAC system at a university. The third time it was hit by lightning, because they put it right behind the service entrance, the insurance company said, no, we're not going to pay this. We're not going to do it anymore until you move that computer. And they did that because I told them that's why it happened. The service entrance is where the noise and the chance for lightning, you could propagate enough fields through the wall just because it's close to the service entrance to cause interference or damage. The radio should go as far away from the service entrance as you can get it. Do spikes dissipate in the wiring of the house further away you get from the service entrance? Yes, unless they're of a frequency or pulse duration that makes the line turn into a transmission line. Then it doesn't, but that's the benefit of having the radio as far away as possible. There's a tremendous amount of inductance in the power wiring in the house out to that point. And that inductive reactance tends to discourage current from flowing, and that's why we don't put ground rods at the other end of the service. What is the importance of putting, where is it? Ground rods no greater than 8 feet separated. That has to do with the continuing topic of a very capable Hammond Cuba who was all over putting his ground rods under the condensate tube of his mini split. That's where the water drains out of the AC system to keep the soil wet. There can't be separation in ground rods because the purpose of a ground rod is to couple electrical energy into the soil, and that assumes the soil is a fairly good conductor. There are optimum distances or maximum distances for putting ground rods in to make them effectively one ground rod. If they're too far away, then the grounded conductor gets too long and too much impedance, and they're no longer grounded together. The wet thing is that his soil is probably like mine, terrible, clay or sand, and it has very poor conductivity, so the water thing is legitimate. But see, very capable ham is not qualification in utility systems, bonding, grounding, and lightning. Hams deal with communications equipment and systems and methods, not electrical engineering related to the utilities and lightning. Who makes sure the ground rod is wet all the time? Nobody. The more I think about this and the subtleties of what you're saying, the more confused I get. That's an indication of lacking of basic knowledge of electrical and RF. Let's say my radio is on the opposite end of the service entrance, maybe 50 feet away. I drive a ground rod in, bond it to the screw on my Astron power supply that's there for ground. What am I doing in reality? I've explained that thoroughly in previous videos. Go watch them. When lightning hits the yard and tries to induce several thousand amp current through the yard and it contacts both these ground rods, it sets up a tremendous high voltage across the electrical wiring in the house. And if that punches through the insulation on that wiring, your house might burn to the ground because a punch through will start AC service power causing leakage current and heating. And if that runs away, it can result in overheating of the cable in the wall and a house fire. Why they put a ground log on a power supply? Because they're idiots. Let's see, power supplies are not radio equipment, and someone that makes power supplies is not responsible for what you do in your ham shack. Is this for tying all the equipment in the shack together but not ultimately back to a ground rod? Yes. Now, if with the qualification of not to a ground rod, then we can start talking about that. Because you see, the root problem is what I showed in my latest video. In fact, this one, of the leakage current from the power supply out to the antenna to the tree. There can be different amounts of leakage current, and that can result in different AC voltage drops on different pieces of equipment and possibly a shock hazard. But you see, grounding them together to put them at the same potential causes ground currents and causes noise and can cause improper operation. The correct answer is to make sure all the AC plugs are polarized the same way. Some old equipment like my Drake, that's not the case. Both the prongs on the power cord are the same width. That's back before we had all this grounding in the outlet. But the proper thing to do is if some piece of equipment has excessive AC leakage to either fix it or put it on an AC isolation transformer. Just connecting equipment together was done back in the day with especially console AM/FM stereos and turntables, where the turntable, the record player, the output is very, very low, and the turntable chassis has to be so-called grounded to the radio chassis, or there'll be a lot of AC hum that just destroys the signal. So, but that's not ground, because the code says only the earth is a ground. That's a common connection from chassis to chassis to try to make sure there's no AC line noise or potential across the two chassis that result in noise on the signal. If you want to connect all the chassis together electrically, there's no particular thing in the code against that. The code says you can't put a separate unbonded ground rod that's not bonded at the service entrance and connect it to anything in the house, because that's modifying the commercial mains service, the branch circuits in your house. The demonstration with the keyer is a little confusing. The point is, if the transmission line goes to antenna wires that are not grounded, and the keyer is triggered by grounding those arms, then that proves that the transmission line shield and center conductor are somehow grounded. Because if you just take a piece of transmission line and connect a shield to the arm of the keyer paddle, nothing's going to happen because there's no contact with ground. And so-called grounding that arm of that paddle out is what triggers the keyer inside the radio. What that does is shows an unexpected and unintentional current path for the AC line current that you don't expect. From the antenna jack out to the yard, this can be sinking currents into the transmitter or the front end of the receiver that aren't good. It can be causing noise. If there's enough AC potential difference, it could cause damage. The last sentence is important. The fact that you're closing the circuit through the keyer, yes, the keyer is inside the radio, but closing the circuit through the paddle arms, which go to the keyer, means that both the center conductor, both the center and the conductor, the outer shield of the coax, are connected to the ground line of the radio and completing the circuit or not. No, the entire point of it is that neither conductor on the transmission line is connected to the ground line of the radio. That's the entire point. It's just the opposite. But it's still finding ground that's coming all the way back through the yard, through the power service entrance, back through all the wiring in the house, and coming back into the radio over a 200 or 300 foot path. And that's closing the circuit. And when that transmission line is touched to the arm on that paddle, that's suddenly made a 300-foot ground loop. And if lightning were to hit the ground then, you kiss the radio goodbye. Because it may drop hundreds or thousands of volts across that, and that's across the radio. So these are all valid and common questions as such in amateur radio. But with all due respect, a lack of understanding of electrical science and RF leads hams that know nothing about this to just, in desperation, try, I'm going to ground something. And it's universally wrong. The amplifier is screwing up a key down. Fix the junk antenna system, because that is what's causing the problem, unless the amplifier is simply broken inside. Maybe a shield inside the amplifier has come ungrounded and just some straight RF is causing a problem. But most of this stuff that lead hams to this improper grounding are either straight RF from bad antenna systems or 60 hertz AC line leakage from a bad power transformer or an old transformer in old equipment that's leaky. And that's creating another kind of shock. If you touch your radio and touch a disconnected piece of coax and get a buzz off of it when the transmitter isn't on, that's AC line leakage. So in almost every case, grounding is not the answer, and it's a band-aid to try to cover up for something that's badly broken. But point is, I've covered all these questions in my previous videos, and if you're coming here new, don't just assume that you can watch the latest video and get in on the topic, because you're missing 7, 8, or 10 other videos that lead up to this. So if you come here and see this video first, then go back to my oldest videos on a topic and start watching them up through time, and you'll find all this stuff is addressed. So hope that helps, did it?